Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in IIT JAM mathematics exam in 2025. In this video, we discuss the solutions of 4 problems from the section Multivariable Calculus related to functions of 2 or 3 real variables. These questions are suitable for all these examinations. Right. This is the question number 27, which is a multiple choice question for 2 marks. The given question is, let F be a mapping from R square to R defined by f of x comma y is equal to e power y multiplied by in brackets x square plus y square for all ordered pairs x comma y belongs to R square. Then which one of the following is true? In all these 4 options, it talks about the number of points at which f has local maximum and local minimum. It is given 1 or 2. Right. So that means our target is to talk about local minimum and local maximum and how many are there for this function f. Let's now discuss the solution of the problem in detail. We have this function, right? You observe that e power y is always greater than 0. X square plus y square is greater than or equal to 0 for all ordered pairs x, y belongs to R square. Therefore, f of x, y is greater than or equal to 0 for all x comma y belongs to R square. And what is the value of f at 0 comma 0? It is 0. Therefore, f of 0 comma 0 is less than or equal to f of x comma y for all ordered pairs x comma y belongs to R square. This means to say that f has a global minimum at 0 comma 0. Therefore, f has a local minimum at 0 comma 0. So we have one point at which f has a local minimum, that is the point is the origin. Right. Now we talk about critical points. To discuss the local maxima, local minimum points, we have to discuss the critical points, for which fx del f by del x is 2x e power y is 0. That will give you x is equal to 0. Fy, that is del f by del y, is differentiate with respect to differentiate f of x comma y with respect to y partially. Then you get e to the power of y into x square plus y square plus 2y is equal to 0. Right. This means x square plus y into y plus 2 is equal to 0. Now for critical points are those points at which fx is 0 as well as fy is 0. So fx is equal to fy is equal to 0 will give you x is equal to 0 and x square plus y into y plus 2 is 0. That means y into y plus 2 is 0. That is y is 0 or y is minus 2. So that is x is equal to 0, 0 and x is equal to 0, 0 and x is 0, y is minus 2, that is 0 comma minus 2. So the critical points are 0 comma 0 and 0 comma minus 2. We have already seen what is happening at 0 comma 0. We have a local minimum at the origin. We need to talk about 0 comma minus 2. Right, we have already seen that f has a local minimum at 0 comma 0. Now we need to check the local minimum, local extrema, or the saddle point at the point 0 comma minus 2. So for all these things we have to calculate the second order partial derivatives. So r is equal to fxx, that is del square f by del x square 2 e power y s t fxy 2x into e power y. S is fyy, fyy. So fx is here, fy is here, fy is here, fyy. You take fy and differentiate partially with respect to y. So you get this one, this one. Now you recall this result. Let a comma b be a critical point of f of x comma y. Let r is fxx, s is fxy, t is fyy at the point a comma b. Then a comma b is a point of local minimum if rt minus s square greater than 0 and r greater than 0. A comma b is a point of local maximum if rt minus s square greater than 0 and r is less than 0. And if rt minus s square is 0, rt minus s square is less than 0, negative, then a comma b is a saddle point. Now we have already calculated RTS, so let us evaluate at 0 comma minus 2. At 0 comma minus 2, r, that is, in all these things, put x is equal to 0, y is equal to minus 2, then r will be 2e to the power of minus 2, which is greater than 0. T will be 2x e to the power of y, x is 0, 0, t is 0. S is, if you put x is equal to 0 and y is minus 2, this x square plus y square plus 2y becomes 0, and here from here you will get e to the power of minus 2 into minus 4 minus 2 into 2 plus 2, that is minus 2 e to the power of minus 2. So RT 0 minus s square, minus into this whole square. So RT minus s square is minus of minus 2 e to the power of minus 2 whole square. If you square it, it becomes plus. So minus is before that, therefore it's negative. So RT minus s square is negative. That means it gives a saddle point. What do you mean by saddle point? See, that is f has no local minima and local maxima at 0 comma minus 2. So at 0 comma minus 2 we don't have local minima and local maxima, but we have already seen f has local minima at 0 comma 0. So therefore f has only one point of local minima at 0 comma 0. Look at our options. So at option C says the number of points at which f has local minimum is 1. So that's the correct answer. So the answer to this question is option C. That is the detailed discussion of the solution of this problem. Great. Let's move to the next question. Yes, this is the question number 31 for 2 marks, which is a multiple select question. That means there can be more than one answer. The given question is, let f be a map from r square to r defined by f of x comma y is equal to xy square plus y to the power of 4, y to the power of 5 by x square plus y to the power of 4 if the ordered pair x comma y not equal to the ordered pair 0 comma 0 is equal to 0 otherwise. then which of the following are true? We have 4 options. So option A says the iterated limits, that is limit x tends to 0 first, then limit y tends to 0. That is one iterated limit. The second one is limit y tends to 0, then limit x tends to 0. The second iterated limit. So do they exist? That's the first question. B. Exactly one of the partial derivatives del f by del x, del f by del y exists at 0, 0. Option C said both the partial derivatives del f by del x, del f by del y exists at 0, 0. So between B and C, one of them must be true. So D, f is not differentiable at 0, 0. First we talk about iterated limits. Solution. So we talk about iterated limits. So now limit x tends to 0, then limit y tends to 0 of f of x comma y equal limit x tends to 0 of limit y tends to 0 of f of x comma y we have written here. So substitute in this as limit y tends to 0, it is 0 by x square. 0 by x square is 0. So limit x tends to 0, limit y tends to 0 of 0 is 0. Limit y tends to 0 of limit x tends to 0 of f of x y. So f of x y we have written here. Limit x tends to 0 of f of x y is you will get the numerator y to the power of 5 by y to the power of 4. So limit x tends to 0, limit y tends to 0 of y to the power of y by y to the power of 4, that is y only. Limit y tends to 0 of y is 0. So limit x tends to 0 of limit y tends to 0 of y is 0. So both the iterated limits exist. So option A is true. Option A is true. Okay. We have taken option B, option C. So we talk about the partial derivatives del f by del x, del f by del y at the origin. So fx at 0, 0, it is same as del f by del x at 0, 0 is limit h tends to 0 of f of 0 plus h, 0 minus f of 0, 0 by h. F of 0, 0 is 0. So it will be limit h tends to 0, f of h, 0 by h. Now go to the f, put x is h, y is 0, this becomes 0. So limit h tends to 0 of 0 by h is 0. So fy at 0, 0, this is nothing but the del f by del y at 0, 0. So limit k tends to 0, f of 0, 0 plus k minus f of 0, 0 by k. So that will f of 0, 0 is 0. So limit k tends to 0 of f of 0, k by k. So go to the f of x y. X is equal to 0 and y is k, you substitute, you will get k to the power of 5 by k to the power of 4 by k. So you will get k to the power of 4 by k to the power of k to the power of 5 by k to the power of 4 is k by k is 1, limit k tends to 0 of 1 is 1. So thus both the partial derivatives exist. Thus both the partial derivatives at 0, 0 exist. So option C is true. And option B is not, option B is not true. This is not D, this is option B. Option B is not true. Right. We are left with option D, the last option. F is not differentiable at 0, 0. Recall the differentiability at a point a comma b. So f of x comma y is differentiable at a comma b if limit h comma k tends to 0, 0 of f of a plus h comma b plus k minus f of a comma b minus h times fx at a comma b minus k times fy at a comma b all by under the square root of h square plus k square. If this limit exists and is equal to 0, then f of x comma y is differentiable at a comma b. So we have to talk about differentiability at 0, 0. So you have to take this, put a is equal to 0, b is equal to 0 in this. Right. Limit h comma k tends to 0, 0 of, in this, put a is 0, b is 0. So then you will get this. In this, f of 0, 0 is 0. fx at 0, 0 is 0. fy at 0, 0 is 1. So what is that we got? So limit h comma k tends to 0, 0, f of hk. So we have taken f of xy, x is equal to h, y is equal to k, we have substituted minus k by under the square root of h square plus k square. So we have taken the LCM in the numerator and we got this one. K to the power of I, k to the power of I cancels, and we get limit h comma k tends to 0, hk square minus kh square by under the square root of h square plus k square into h square plus k to the power of 4. Let h comma k tends to 0, 0 along k is equal to mh, like y is equal to mx. Right. Now substitute here, then limit h tends to 0 of h into, wherever there is k, substitute mh. Wherever there is k, mh. Wherever there is k, mh. Substitute. Now you will simplify. You will get m square minus m into h cube by h into under the square root of 1 plus m square. h square into 1 plus m square h square. It is not m power 4. It is m square. It is m square h square. So h square into h in the denominator is h cube. In the numerator is h cube, cancels. You will get this one. Limit h tends to 0. This will be m square minus m by root of 1 plus m square. So this depends on m and varies from path to path. Therefore, the limit does not exist. The limit does not exist. Therefore, f is not differentiable at 0, 0. And we have already seen options A and C are true and the option D is not true here. So therefore, the answer to this question is options A and C. That is the detailed discussion of the solution of this problem. Right. We move to the next question. This is the question number 34, which is again a multiple select question for 2 marks. The given question is, let f be a map from R square to R defined by f of x comma y is equal to x square plus sin x whole in the bracket multiplied by y square by in the denominator x square plus y square if the ordered pair x comma y not equal to the ordered pair 0, 0 is equal to 0 otherwise. Then which of the following is or true? Right. Options A and B talks about the limit of f of x comma y as x comma y tends to 0, 0. Is it existing? If it exists, is it 1 or 0? That is options A and B. Option C and D talks about differentiability. Is it differentiable at the origin or not? Let's now discuss the solution of the problem in detail. We first talk about the limit of the function f of x comma y as the ordered pair x comma y tends to 0, 0. And for this question, as we see that there is a factor like x square plus y square which is sitting in the denominator will indicate to you that you go for the substitution of the polar system x is equal to r cos theta, y is equal to r sin theta. In this, the things would become difficult, would become easy. Right. F of r cos theta, comma r sin theta, substitute in this, x is equal to r cos theta and y is equal to r sin theta in this. So if you substitute, you will get r square cos square theta plus sin of r cos theta whole into r square sin square theta by r square cancels. So this is r square cos square theta sin square theta plus sin of r cos theta into sin square theta. Right. Now take the limit. Now limit x comma y tends to 0 comma 0 of f of x comma y is limit r tends to 0 of f of r cos theta r sin theta. This is limit r tends to 0 of the first factor r square cos square theta sin square theta plus limit r tends to 0 of the second factor, that is sin of r cos theta into sin square theta. Right. So now in this, cos square theta sin square theta will come out with nothing to do with the limit. That's what we have. And in the second also sin square theta will come out. And this is the thing. Now limit r tends to 0 of r square is 0. And you further note down this is bounded. This is bounded. Right. Here also sin square theta is bounded. And as r tends to 0, sin of r cos theta tends to 0. As r tends to 0. As r tends to 0, sin of r cos theta tends to 0. Because it's a continuous function. For that reason. Right. So this entire thing will become 0 plus 0 is equal to 0. So there's, it exists. It exists. That is, the limit exists. And the value of the limit is 0. So option A says it exists, but the value is 1. So option A is not true. Option B is true. Right. We move to the next slide. Option C, f is differentiable at 0 comma 0. Option D, f is not differentiable at 0 comma 0. We don't have first order partial derivatives so far, therefore we compute now. The first order partial derivatives, fx at 0 comma 0, you know, limit h tends to 0, f of 0 plus h comma 0 minus f of 0 0 by h. F of 0 0 is 0. This is limit h tends to 0 of f of h comma 0 by h. Substitute in this. This is 0. Right. Fy at 0 0 is limit k tends to 0 of f of 0 comma 0 plus k minus f of 0 0 by k, and f of 0 0 is 0. This is limit k tends to 0 f of 0 comma k by k. Now f of 0 comma k, x is equal to 0, y is equal to k, is substitute, this will be 0. So it is 0. So both the first order partial derivatives at the origin exist and they are equal to 0. Let us recall f of x comma y is differentiable at a comma b if limit h comma k tends to 0 comma 0 of f of a plus h comma b plus k minus f of a comma b minus h times fx at a comma b minus k times fy at a comma whole by under the square root of h square plus k square. If this limit exists and is equal to 0, then it is differentiable at a comma b. Now take limit h comma tends to 0 comma 0. So in this, wherever there is a, substitute to 0, b for b substitute 0. So it's like this. F of 0 0 is 0. Fx at 0 comma 0 0. Fy at 0 comma 0 0. So all these are 0. Then you will get limit hk tends to 0 of fhk by under the square root of h square plus k square. Fhk we have written here. So f of xy we have written here. Right. Limit h comma k tends to 0 of h square plus sin h into k square by h square plus k square whole to the power of 3 by 2. H square plus k square multiplied by under the square root of h square plus k square. Let h comma k tends to 0 comma 0 along k is equal to mh. Right. Then limit h tends to 0 of h square plus sin h into for k mh m square h square by h square plus k square is m square plus h square whole to the power of 3 by 2. Numerator is as it is. In the denominator you will get h square. When coming out of the 3 by 2, this becomes h cube into 1 plus m square whole to the power of 3 by 2. Right. H square by h cube, h remains then you will get m square by 1 plus m square to the power of 3 by 2, which is constant. Limit h tends to 0 of h square plus sin h by h. H square by h is h. Sin h by h is sin h by h. Right. Limit h tends to 0 of h is 0. Limit h tends to 0 of sin h by h is 1. This is 1. Then you will get m square by 1 plus m square to the power of 3 by 2. This depends on m and varies from path to path. Therefore, the limit does not exist. Therefore, f is not differentiable at the 0, 0. So, f is not differentiable at 0, 0. That's the option D is true. Option C is false. Option C is not true and option D is true. And we have already seen option B was true. Therefore, the answer to this question is options B and D. And that is the detailed discussion of the solution of this problem. Right. We move to the next question. Right. This is the question number 50 for 1 mark. It is a numerical answer type. The given question is, let f be a map from R square to R defined by f of xy is equal to x square minus y square in brackets multiplied by xy by x square plus y square when the ordered pair x comma y not equal to 0, 0 is equal to 0 otherwise. Then the value of del f by del y at 1, 0 minus the value of del f by del x at 0, 0, 0, 2, del f by del y at 1, 0 minus del f by del x at 0, 2 is equal to, you have to round off to 2 decimal places. So, del f by del x at 0, 2 first we compute. So, the limit h tends to 0, f of 0 plus h, 2 minus f of 0, 0 by h. F of 0, 0 is 0, limit h tends to 0 of f of h, 2 by h. So, in this substitute, x is h, y is 2. So, limit h tends to 0 of this one. So, the h cancels, you will get limit h tends to 0, 2 times h square minus 4 by h square plus 4. This is, after taking the limit, you will get 2 into minus 4 in the numerator by 4, that is minus 2. Del f by del y at 1, 0, limit k tends to 0, f of 1, 0 plus k minus f of 0, 0 by k, f of 0, 0 is 0. This will limit k tends to 0 of f of 1, k by k, and go to the f of x, y, and put x is equal to 1 and y is equal to k and write down, and limit k tends to 0 of this one. Now the k cancels. K cancels, you will get limit k tends to 0 of 1 minus k square by 1 plus k square, that is 1. So now del f by del y at 1, 0, that is 1, minus del f by del x at 0, 2 is minus 2, minus of minus 2. 1 minus of minus 2, that is 3. So therefore, the answer to this question rounded off to 2 decimal places is 3.00. Right. That is the detailed discussion of the solution of this problem. So in this video, I have discussed 4 problems from the functions of 2 variables, functions of 2 real variables, and in this, how to find the limit, how to calculate the partial derivatives, right, and how to decide the differentiability in one variable and the differentiability in 2 variables. They are same, but the criteria is entirely different, right? And the functions of 2 variables, we talked about the points of minima, local minima, the points of local maxima, and the saddle point. So these are some of the topics that are very, very important in the point of view of any examination. And if you work out these problems, it will be a practice for you. For especially CSIR NET students, it will be a practice. And I have been telling to you that you practice the questions that have come in IIT JAM examination. That will be helpful, and it will help you as a practice for your NET examination. With these few words, I say, I am sure that you have understood the solutions of these problems. Thank you for watching this video now. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Yes, I am sure that I am going to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.